This last lecture in survey design and components deals with the data analysis that we're going to do. Probably the most difficult component of survey research, or really any research, is the statistical analysis, because we probably just aren't exposed to the statistics that we need to in order to properly analyze the data that we've collected. It does take quite some time and quite a few classes to get up to speed with that. But it doesn't mean that we can't quickly understand and interpret the results and be able to report that out for our survey research, right? So that's kind of our ultimate goal, is to become familiar maybe with some survey research design articles, understand what things like Pearson and R-squared and p-value mean when we're looking at it. And then again, be able to report out some different components of the research that we've done. Now some of those things may sound foreign or alien, but there's not a lot we need to look at in order to determine if our results are, where we can reject or accept the null hypothesis. So let's look at some of these, some of the data analysis components. And of course, we're going to need a computer program to do that. Some smaller studies you can do in Excel. Excel has a data analysis package that you could put as an add-on for free. You just need to activate it within Excel. And you could do some kind of inferential statistics with that. You can't get overly complex. It's a little difficult sometimes. There's also Excel Tab, which you could buy, that does more statistical analysis. Probably the most used is a program from IBM called SPSS, and that is a very powerful statistical analytical tool, but it's also very expensive too, so we wouldn't expect you to go out and buy SPSS. But some of those resources are available through the institution. So depending on the level of analysis that you do, SPSS may be required. So in terms of the steps of data analysis, you want to report the number who did and did not respond. So it's very important for a reader or somebody who's evaluating the research to understand who responded and who didn't. How many of your participants responded and how many didn't? And why do you think the reason that is? So if I send out 2,000 surveys via maybe an internet SurveyMonkey or something like that and get 1,000 responses, my response rate is 50%. And that in and of itself could be problematic. Why did so few of the people who were solicited respond to the survey? Why did those who responded respond? And why did those who didn't, why didn't they? And you could say something like, well, maybe the people who didn't were a little leery of technology, or they're not as technologically savvy as the people who did. But then you could see that could also throw a little wrench in your research, because now maybe you're separating out tech savvy from non-tech savvy participants in your survey, and that could also be problematic. So that's why you want to say, here's who I give the survey to, here's the number who responded, here's why I think some of these did not respond, or here's why, there may be some participants too who leave a question or two blank, and then you'll have to figure out a way to kind of get around that or statistically manipulate that, so you're not throwing away every survey because somebody missed one question. So the number of people who didn't respond. The method to determine response bias. Now, again, there's a lot of different methods you could look at. There's a lot of different reasons why people may or may not respond or respond in the way they do. I'll give you an example. So if you're doing let's say we're going back and we're looking at optimism again, we're going to measure how optimistic an individual is. Well, if that individual is having a good day, they may respond differently than if they're having a bad day. So in order to kind of wash that out and eliminate that in the research, I might give what it was called a positive and negative affect survey before I give my actual survey. When I give that, I can kind of determine the mood of the person who's taking the survey, and then I could co-vary that into the result to kind of smooth out whether somebody's having a real good day emotionally or a real bad day. So there are ways that I could kind of temper the response and eliminate some of the bias in the responses. Plan to provide descriptive analysis. So when I'm doing research, I want to explain, here are the participants. Here's the demographics. Here's a breakdown of who they are. Gender, I shouldn't even say demographics in accordance to what may or may not be important in the survey, right? So if age might be important, if gender might be important, if level of education might be important. I want to report on those things and maybe present them in simple graphs or charts. I want to calculate total scale scores. So in essence, I want to start doing my calculations. I want to start doing my statistical analysis through SPSS or Excel or whatever it is that I'm using. And I want to make sure I'm using the right, not only the right software, but the right program, the right analytical tool for what it is that I'm examining and what type of data I collected, right? So again, a little more complicated when it comes to that because you're talking about parametric versus non-parametric statistical techniques. But you know, if I'm doing a correlational study, I'm going to use regression, right? And I know if I use regression, I'm going to be looking for certain output from that. So I need to be familiar and know what that is. Some programs, you have to actually manually program what it is you're looking for, but with things like SPSS, it's a very easy interface where you can go data analysis, regression, bivariate, here's my two variables, boom, here's the results, and you're on your way. And sometimes it can take as little as 5 minutes to do that type of analysis. I want to then present the results in figures or tables and interpret it. So the APA catalog has, the APA manual has formatting for what statistical test you're doing and how you need to report it. These are the figures that you need to report, whether it's a p-value, whether it's an r-squared value, whether it's a beta variable, whatever it is, it's going to, Pearson, it's going to tell you, here's what you need to do, here's how you need to present it. You know, I highly encourage you to review the APA manual too and understand how those need to be reported. But also, you know, I tell students, as you're reading some of these articles, as I have you go out and find survey articles or experimental research articles, look at the statistics. Just try to kind of get a picture of what they're doing and what they're reporting and how they're reporting it. You may not understand it all, but you know, if you look at a p-value and say, okay, their alpha was 0.05, their p-value was 0.03, which means the results are significant. Anything under a 0.05 is significant. If you're doing a correlational study, you might look at the r-squared. The r-squared pretty much tells you the effect. So if I have an r-squared of 0.2 or 20% with my hours worked and stress level, what I could say is hours worked has an impact on the level of stress to the tune of about 20%. So 20% of the stress that these people are feeling here, I think it was nurses in emergency room, 20% of that can be related back to the number of hours that they work. Now 80% is something else. 80% could be the trauma they see, it could be family life, it could be any number of things. But they're feeling stressed for a number of reasons, not just one reason. And you're trying to figure out what can comprise that. And if we look at stress, we can say if we have an r-squared value of 0.2, 20% of the stress that they're feeling is a result of the hours that are worked. So if you could just become familiar with some of those indicators and some of those statistical outputs that say this means this and this means that, it's going to make reading the articles much more enjoyable, but also you're able to start to evaluate the results of what's being presented. Report how the results answered the research question or hypothesis. Practical evidence in terms of effect size and confidence intervals. Effect size is just what we talked about, the r-squared, 20%, 15%, whatever that is, and a confidence interval between this number and this number. I'm 95% sure that the results will be between here and here when we do future research and studies. And discuss the implications, right? What does it mean? How does it align with the current literature? How does it refute what's been determined or what's been known to be understood so far? How is it consistent with what's been known so far? And how do we build upon previous research, right? So those are some of the things we definitely want to talk about. We want to talk about the implications of the study. Talk about it, you know, in a narrow scope first, and then maybe what it can mean to a broader audience or into the population itself that we're trying to study. And then, of course, where could other studies be done? Okay, so that's talking about the data analysis. Again, very complicated. It's something that you have to kind of walk before you run into. But it's, instead of just kind of glossing over, skipping over some of those analysis and presentation of data, look through it. You'll start recognizing some familiar symbols and numbers, and as you do, you'll definitely become more comfortable with looking at the analysis and trying to interpret the results.